Hey guys, welcome to question MM416 of the Maths Methods Fortify study guide. So in this question we've got a snack food company which sells packets of corn chips at a variety of supermarkets. The net weight of a corn chip packet is a random variable C grams, which is normally distributed with mean 169 and standard deviation K. Now part A says 85% of all corn chip packets sold weigh less than 172 grams and we need to find the value of K. Awesome. So part AI, it's a 3-mark question. Cool. And what we need to do is figure out the corresponding Z score for this X value. Okay, so this is our X value, or actually I should say C value. So our C value at this point is 172. And we know that 85% of the data lies below that point, right? So in order to find the Z value at this point, because we want to find how many standard deviations away from the mean this is, we need to use our inverse normal, okay? This is in our CAS, in mine it's menu 553. So what we're going to be asked for is our area, our mean, and standard deviation. So our area is the probability that it lies below this point, which is 85% or 0.85. So with an inverse normal, we always take the area to the left of the point that we're looking at. In this case, that 85% is to the left, so that's fine. Mean is our 0, because we're wanting to find our Z score, which corresponds to how many standard deviations away from the mean we are. So that's our 0. Standard deviation is 1 in this case. We just use 0 and 1 whenever we're finding our Z value. What this spits out is Z equals 1.04. That's our first mark. Now, our second mark comes from recognizing what we have to do from here. So Z, we use our, universal formula that links Z and X. So we say that Z is equal to X minus mu over standard deviation, and therefore we know our X value is 172. We know our standard deviation, our mean in this case is 169. We don't know what our standard deviation is because that's what we're actually trying to find, but we do know that our Z value is 1.04. Okay, so there's that second mark. Now our third mark comes from actually answering the question. So we can rearrange this, and what we get is standard deviation equals 172 take 169 over 1.04, which gives us 2.895. So therefore, K is equal to 2.895. Because remember we have to find K, not just the standard deviation. We actually have to state what K is. Awesome. Now, that's it. So that's our third mark. Let's move on to part AII. Part AII is a 2-mark question and tells us that a randomly chosen packet of corn chips weighs less than 172 grams. What is the probability that it weighs more than 168 grams? Awesome. So what we're essentially saying is we're looking for the probability that this packet weighs more than 168 grams, but we know that it weighs less than 172. Okay, so we can say given that it weighs less than 172. Okay, so this is a conditional probability formula. Now according to our conditional probability, A given B is equal to A, which is 168, intersect B over the probability of B, which is C is less than 172. Awesome. Now we can use our normal CDF to find our probability of this. So the intersect between greater than 168 and 172 is exactly that. So 168, C, 172. So between those two values, probability that C is less than 172. Now, using our normal CDF in our CAS, we use this because we know our upper and lower limits, we know our standard deviation, mean, all that sort of thing, but we don't know our probability, and that's exactly what we're trying to find with this. So, lower, upper, mean, standard deviation. Our lower, in this case, is 168. Our upper is 172. Our mean is 169. And our standard deviation is K, which in part AI we found to be 2.895. Awesome. Now, what this spits out is 0.4851, which means that this is now equal to 0.4851 over the probability that C is less than 172, which part A told us was 85%, right? So everything below 172 was 85%. so 0.85. Awesome. Putting this into our CAS, we get 0.5707, which is our probability that C is greater than 168, given that C is less than 172. And that's our final answer. So that's our second mark, guys. Our first one comes from actually finding this bit here, and our second comes from plugging everything in. So that's it for part AII. Let's move on to part B. Part B is a 3-mark question, and is actually a little tricky, especially haven't seen one like this before. So, got part B, 3 marks. Now it says the company would like to be sure that a certain proportion of corn chip packets are within a certain weight range. After taking a sample of 100 packets, they are P% sure that between 80 and 90% of corn chip packets will weigh more than 171 grams. Find the value of P correct to the nearest integer. Alright, awesome. So, if they're 80 to 90% sure, that means that our confidence interval is 0.80 to 0.90. Okay, that's our confidence interval. Now, in order to find our percentage certainty or percentage of confidence, that's what our P value is here. Because if we're if we were 95% sure, that means that this would be a 95% confidence interval. Okay. And what determines our 95% confidence interval is our Z value within our confidence interval. So our confidence interval is given by P hat minus Z, P hat 1 minus P hat over N, P hat plus Z, P hat 1 minus P hat over N. Awesome. Now, this Z value is what determines our percentage of certainty, okay? So we need to find this Z value in order to work that out. So this 0.80 corresponds to this section here, and this 0.90 corresponds to this section here, because that's our lower and our upper, which means that these two equal each other. So we can say that one of these is equal to the other. So 0.80 is equal to this lower bound, which is P hat minus Z, P hat 1 minus P hat over N. Now, our P hat is always halfway between our confidence interval, okay? So halfway between the lower and the upper. So what's halfway between 80 and 90? 85. So 0.85. So our P hat is 0.85. We don't know what our Z is. That's what we're actually going to try and find out. Again, P hat is 0.85. And then 1 minus 0.85 over N, which is our total amount of packets, or our sample size, which is in this case 100. So we have 0.8 there. And this is actually our first mark. Awesome. So now our goal is to find out what Z is. So rearranging all of this, what we get is 0.05 equals Z times root 0.85 times 0.15 over 100, which gives us 0.0357Z, 0.05. Please excuse the noise outside if you can hear that. They're doing some roadworks and stuff. So, from here, Z is equal to 1.4003, and that is our second mark. So what this means is that on a normal distribution scale, got our mean of 0, which is our Z value mean of 0. If our Z value is 1.4003, it means we've got 1.4003 here, and then we take our negative version as well, and the area between here is the percentage sureness, or certainty. I don't think sureness is a word, but the certainty, right? So we are P% sure, and this is our P%, okay? So the way that we find that is by finding the probability between these two sections, right? So what we do is we grab our normal CDF in our CAS, our lower, upper, mean, standard deviation. So our lower is negative 1.4003, our upper is 1.4003, our mean is 0, and our standard deviation is 1. Now what this gives us is an area, or a probability, of 0.8386, which means that we're 83.86% confident, which means that we're 84%, which means that P is equal to 84. And that's our third and final mark for part B, guys. If you have any questions about this, let me know. But for now, let's move on to part C. Now, part C is a 2-mark question, and it says the company keeps testing their products. in a different test, they take a sample of 25 corn chip packets. What is the probability that more than 10 of them, weigh between 168 grams and 172 grams? Awesome. So what we're looking for is the probability that the weight lies between 168 and 172. Awesome. Now, we know that the probability of one of these corn chip packets being between this weight is 0.4851. That's from our part AII. We found that out then. So that's what we're looking for. Well, that's what we know at this stage. So then what we have is our fact that we have 25 sample packets. So we have n equals 25. And what we're dealing with here is our binomial distribution, okay? Because any corn chip packet has a 0.4851 chance to be in this weight range, regardless of what other packets weigh, right? We've got a certain number of trials, we've got that probability, they're all independent, which means we're going to be dealing with binomial. So, binomial CDF is going to ask us for lower, upper, N, and P, and our lower is going to be 11, okay, because we're looking for the fact that more than 10 of them have that weight range, okay? So we don't use 10 as our lower because it's not including 10, we use 11. Our upper is going to be 25 because we're dealing with more than 10, and our total sample size is 25, so n equals 25 as well. And then our P is 0.4851, which we found in part AII. So this is all our first mark. And then plugging this into our CAS, we get the probability that x is greater than 10 or more than 10 being between that weight range is 0.7418, which is our second and final mark for part C. And that actually wraps up MM416, guys. If you have any questions about any of this, as always, please hit me up in the comments below. But otherwise, thank you for watching and have an awesome day.